Integrating 1 over x is the only power function that needs its own rule. And the reason for this is if we just did a regular integration and just said, hey, that's the same as x to the power of -1, then we'll increase the power by 1, we get 0, and we divide by 0, which you can't do. And so that is not the way to integrate 1 over x. Instead, we need to remember that if we had y equals ln x, that differentiated to 1 over x, which means the integral of 1 over x dx is equal to ln of x plus c. Now, this is in absolute value bars, and the reason for that is that the graph of 1 over x looks like this. It is a hyperbola, which is true for all x values except for 0, whereas the graph of ln x only looks like that, which is only on the positive side of the y-axis, which means it won't work for any negative x values. And so putting the absolute value bars in allows us to do it for negative x values. So let's look at how this works in action. Integrating 7 over x, well, that is just the same as integrating 7 times 1 over x, which gives us 7 ln x plus c. Number 2, integrating 2 over 3x is the same as integrating 2/3 times 1 over x dx. So that gives us 2/3 ln x plus c. Number 3, in number 3, there's nothing I can take away from the bottom. That will give me just 1 over x, because that 2 is involved in the 2x but not the plus 1, which means I have to rewrite this as, well, that's the same as 4 times 1 over 2x plus 1. And when I'm looking to see if the power on the bottom of the fraction is 1, I look at the whole denominator and treat it as one thing, so that would be to the power 1. So this will equal 4 ln, and I put the whole denominator in, 2x plus 1, and then just like before, we're divided by the derivative of the brackets. I'm going to divide by the derivative of this bracket, which is over 2 plus c, gives me 2 ln 2x plus 1 plus c.